Hello, YouTube learners, students, friends, and colleagues. Once again, this is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. For now, this will be the last video in the series of 3 talking about abstract classes in C++. I might do a 4th one to show a polymorphic sorting function based on abstract class pointer array, but I'm not sure when that will be done. Okay, a lot of other work to do, really. So let's get started here. This time today, in this third video, we're going to take a abstract class, not concrete. An abstract class that will have both pure virtual function and data member. So when you add data member, that's a partial design. That's the regular inheritance partial design. And when you add pure virtual functions, that's the behavioral inheritance part of the design. So two designs are kind of combined together in abstract classes that might have data member that are inherited by all the child classes. Okay. I may do some review. Understand that contract with the base abstract class is only the child class will override its pure virtual functions. The algorithmic detail inside the origin functions are not part of that contract. Each child class can design the code inside the body of origin functions any way it sees fit. Child classes have total freedom to implement code inside the origin functions in any manner they need. Okay? That's the flexibility part of it. All right. We want to design a class called Mammal. That will be abstract class. And we want to derive some classes from that. According to biological science, humans are classified under mammal. So we can say human is a mammal or a person is a mammal. So in that case, with mammal being the base class, person class can be derived from it. And since we are not interested in instantiating an object of class mammal, because I cannot go around and point to any living being in the world and say it is just a mammal. We will be something more than that. So we'll make a mammal as an abstract class. Similarly, students in a college are related to human beings by the relationship that a student is a person. So we can derive student from the person class. Okay, and we can keep going with this derivation. We can derive a graduate student from the class student, but for now we're just gonna stop right there. And this inheritance hierarchy, base class being mammal, person being derived from mammal, student being derived from the person, is shown in this picture right here. Mammal will be abstract because we're going to put some pure virtual function in it, and we don't need to instantiate mammal. Person derives from mammal. It will inherit all the public, it will inherit everything. And then student derives from the person. Logic is person is a mammal, student is a person. Okay. So we are going to add age as a data member because all mammals have age. and then all persons have name. Actually, all mammals have age. Name is kind of optional. And all the students have GPA. So we're going to add some data members at each level. So age at the mammal level, name at the person level, GPA at the student level. If we make this protected, then person has 2 data members, age and name. The student has 3 data member, GPA, age and name. Okay. 2 pure virtual functions are added to the member class, print and getAge, and there will be more non-overridden function in the student and person. Okay, so we're going to show details in the Xcode. Let's go to Xcode or compiler. So this shows the inheritance hierarchy. Mammal is the base class, person derives from mammal, student derives from person. So let's see, and these are the methods, functions, but we'll look at them very quickly here. So first, the mammal class has protected data member called age because all mammals will have age. And then I have a constructor that takes age as a data member, and I use the initialization list to assign init age to age. Default value is just a impossible value for now. And then realize we have 2 pure virtual functions, getAge and print. So all the child classes like person and student will have to override that and make them, you could still make them virtual, but they cannot remain pure virtual anymore. So bodies have to be given. I added the virtual destructor because you could add a virtual destructor, although destructor doesn't do anything because it helps identifying an object at the runtime. We won't do anything with that in this video, but maybe in the future. But just remember that always put a virtual destructor in every class, whether it does something or not. Runtime type identification becomes easier for that. Okay, so I'm driving person from mammal, and if I want to instantiate an object of a person type, it should override these 2 pure virtual functions. They can remain virtual, but they cannot remain pure virtual. So let's see what we did here. So we added one more data member, name. I'm calling it mName. And here I removed the pure virtuality aspect. So now they're only virtual, not pure virtual. And the full code is right here for the constructor. The code is very simple. Oh, wait a minute. Okay, so I guess I moved the full definition a little bit later. Okay, I can show it to you. Yeah, it's right here. In fact, I will move it up to make it a little bit easier to see. Let's move it right here. Yeah, there we go. Much easier. So person class constructor takes argument for name and age, because if you go back to our inheritance diagram, age was in the mammal class, person derives from mammal. So it will inherit this one and it has this one. Okay. So constructor takes 2 arguments. Age part is built by the mammal class constructor. So in the initialization list, we pass that first. Name part is initialized right here. So that's my person class constructor. Print is a pure virtual function. You saw that right here. So we override that one, and sorry, that's pretty easy. Just print the name, print the age. Get age is a pure virtual function, and I have to override that, and I'm overriding that right here. Okay. Then student derives from person. It adds a data member called GPA, mGPA. So it's going to have three data member: age, name, and GPA. So constructor needs three arguments. I provide default value for all the arguments. Constructor body implementation is right here, and we call its superclass person constructor with name and age, and initialization list initialize the GPA member, and of course when person class constructor is called, it calls the mammal and does the name initialization, and construction sequence goes from top to middle to bottom. Okay. And then since base class mammal has these two as pure virtual functions, those are overridden and overridden right here and here. So now we have completed all the formalities of overriding pure virtual functions in the mammal class, doing the constructors and everything. Now we can use a very basic and important property of inheritance, that base class mammal pointer can store address on any of the child class and call either both or one pure virtual functions. Now I wanted to point out one more thing. When I do this syntax here, that means call the print function of the person class, because that already prints name and age, and all you need is a GPA. So you just print the GPA that was added at the student class only. So you just print that. So for student you will get everything printed, because print function of person class prints name and age. Okay. All right. So now I want to use my pointer of the base class mammal to create object of person student type. So I do that here. Pointer M1 stores address of new person, name is Joe Man, age is 30, and then I print it. I call the pure virtual function print that was overridden by the person class, so I get the correct object to function in binding, and I use object pointer M2 to store the address of student, age, GPA, and I print that. So and then since I did a new, I do these two deletes to delete the dynamically allocated memory, so my program does not have memory leak. Okay. So let's run this program, and then we're gonna copy code and output side by side and see how that works. So that's my output, that's my code. So let me copy, deletes will work, I don't need to worry about that. So go to Microsoft Word, in one column I can add to a table here code, okay. And on this side I'm gonna print the output. Okay. Sorry, I didn't get, okay. Match destination format. I have no idea. It's not printing for some reason. Okay. That should not have happened. Let me just print one line. So copy, paste, or maybe keep text only. How about that? Okay, somewhere it's not printing from there, but that's okay. We can look at code and output line by line here. So when I did Mammal M1, new person, so name was set to Joe Man, age 30. And when I do M1 arrow print, printing through the pointer M1, calling the pure virtual function that was overridden by the person class, I get Joe Man 30 years. And then I had Jane Adams, age 22, GPA 3.7, address stored in pointer M2. Print was pure virtual function overridden by student class. So that is called now, makes the dynamic binding, name Jane Adams, age 22 years, GPA 3.7. Okay, so now I was trying to do array of abstract class in video 1 or 2, but really array of abstract class is not allowed, but array of pointer of abstract class is allowed. So I'll just take a couple of minutes to show that concept. So let's say I have a mammal pointer ARR, and let's put 5 elements in there. That array is allowed. Array of pointer of abstract class is allowed. And then I can store new person and new student in that. So I could do that now, that ARR 0 is simply M1 and ARR 1 is simply M2. You could have just done new student, new person here. Instead of M1, you could have just put this line here. Okay, forgot the equal sign, sorry. And so the point here is that an array of pointer of abstract class can hold address of all the child classes. Okay. Sometimes that's very useful for creating polymorphic sorting functions. We won't go into that now. but we'll do that in future sometime. And now you can see that you can make the same calls actually. So ARR 0 arrow print will work just the way this one did. It has to. And ARR print works the same way. And comment out this one. Comment out this one. And you'll see that my output is not going to change. Compiles and output doesn't change. Yeoman 30 years, Jane Adams 22 years, GPA 3.7. Better use of this array will be to pass it to a sorting function, and then sort it maybe based on age or name type of things. Okay, and that's a very powerful use of inheriting from an abstract class. Okay, thank you. This video is over, and